Hello students, welcome to grade 12 chemistry revision lesson on determination of the rate law. At the end of this lesson, you will be able to determine reaction rates using experimental data and calculations. Determine the rate law and order of reactions from data on initial concentrations and reaction rates. Explain the zero order, first order and second order reactions using concentration versus time curves. Students, if you are ready, then we will get started. The initial rate method for the reaction AA plus BB to form CC plus DD. Initial rates equal K is rate constant, times initial concentration of A to the power of M times initial concentration of B to the power of N, where M and N are obtained experimentally. For example, the reaction 2NO gas plus Cl2 gas to form 2NOCl gas was studied at 266 Kelvin. And the following data were obtained. This is data obtained experimentally. You are asked to calculate order of the reaction. Determine the rate law for this experimentally obtained data. What do you do? Your first step is to write the rate law for this reaction. Now the rate law for this reaction is R equal K times concentration of nitrogen monoxide to the power X times concentration of Cl2 to the power Y, where X and Y obtained experimentally. Now to get the value of X, vary concentration of NO while keeping concentration of Cl2 constant. Therefore, concentration of NO vary in experiment 2 and 3. Concentration of Cl2 is constant in experiment 2 and 3. From this 1 over 2 to the power x, 1 over 2 to the power x equal rate 2 divided by rate 3 is 36 divided by 144, which is 1 over 4 equal 1 over 2 to the power 2. The bases are equal, therefore x equal 2. X equal 2. To get the value of y, vary concentration of Cl2 while keeping concentration of nitrogen monoxide constant. Therefore, in experiment 1 and 2, concentration of nitrogen monoxide is constant. Concentration of Cl2 is vary. 1 over 2 to the power y. 1 over 2 to the power y equal rate 1 divided by rate 2 is 18 divided by 36 is 1 over 2. From this, the value of y is 1. Therefore, the rate law for this reaction is R equal K times concentration of nitrogen monoxide to the power x. The value of x is 2. 2 times concentration of Cl2 to the power y. The value of y is 1. Therefore, order of this reaction with respect to nitrogen monoxide is 2. Order of this reaction with respect to Cl2 is 1. Overall order of this reaction is 2 plus 1, 3. Concentration time equation or integrated rate law. Integrated rate law express the concentration of a reactant as a function of time. Integrated rate equation enables us to calculate concentration of a reaction at a given time. The rate of a reaction does not depend on the reactant concentration for zero order reaction. Therefore, for a simple reaction A to B or A to product, rates equal in terms of concentration of reactant equal minus changing concentration of A divided by changing time equal for a zero order reaction Chem times concentration of A to the power 0. Using calculus, we can write this as minus change in concentration of M divided by change in time equal K times concentration of A to the power 0. Rearranging this, we can write this as minus change in concentration of M divided by concentration of A to the power 0 equal K times dt. Integrating both sides, we get an integrated equation for zero order reaction equal concentration of M at any time t equal minus kT plus initial concentration. Now this is integrated rate equation for zero order reaction. Concentration of M at any time t equal minus Chem is rate constant times T is time plus A naught is initial concentration of the reactant A. This enables us to calculate concentration of the reactant at any time T is integrated rate equation for zero order reaction. Graphically, we can represent a zero order reaction. An integrated rate equation for zero order reaction is this: concentration of M at any time t equal minus kT plus initial concentration A naught. Now this is similar to equation of a straight line, which is y equal mx plus b. Now a plot of concentration of M versus concentration of M versus t is a straight line with slope minus k. For example, the decomposition of a reaction 2M to 2C plus D is zero order reaction that occurs on the surface of metals. The concentration of A reduced from 0.4 molar to 0.1 molar in 20 seconds. Find the rate constants of this reaction. What is given? Given initial concentration A naught equal 0.4 molar. Concentration of M at time t is 0.1 molar. Time t in second is 20 seconds. You are asked to calculate the rate constant K. Now for a zero order reaction, an integrated rate equation is this: concentration of M at any time t equal minus kT plus M naught initial concentration. From this, concentration of M at time t minus initial concentration divided by t equal minus K. Concentration of M at time t when t is 20 seconds is 0.1 molar minus initial concentration is 0.4 molar divided by t is 20 seconds equal minus K. From this, K equal 0.1 minus 0.4 is minus 0.3 divided by 20 times minus 1. K equal 0.015 molar per second. The units of rate constant for zero order reaction is molar per second. Therefore, the value of K is 0.015. First order reaction is a reaction that doubles its rate when the concentration of a reactant is doubled. For a simple reaction A2 product, rates equal minus change in concentration of A divided by change in time equal K times concentration of A raised to 1. Using calculus, we can write this as minus change in concentration of M divided by change in time equal K times concentration of M to the power 1. Rearranging this minus change in concentration of M divided by concentration of M equal k times dt, integrating both sides. The integration of minus 1 over a, changing concentration of a, equal k times dt. When t equal 0, we have initial concentration a naught. At time t, the concentration of m become this concentration of a at time t. Now, the integration of 1 over x dx is ln x, ln x. Therefore, the integration of 1 over concentration of m is ln m. Now we can write this as, this is the same as minus the integration of 1 over concentration of m dm equal k is constant. You can factor out k times the integration of dt is the same as t to the power of 0 dt. Multiply both sides by negative 1. This become ln concentration of m from a naught to concentration of m equal k times t raised to 0 dt is kt minus kt. Now, an integrated rate equation for a their order reaction become ln concentration of A from A naught to concentration of M is the same as ln concentration of M at time t minus ln concentration of A naught equal K times T minus K T. This is an integrated rate equation for first order reaction. Ln concentration of M at any time t minus initial concentration equal minus Kt. Graphical representation of first order reaction. As we said, an integrated rate equation for a first order reaction is this: ln concentration of M at any time t equal minus Kt plus ln concentration of A naught initial concentration. Now this equation is similar to equation of a straight line, which is y equal mx plus b. Now a plot of ln concentration of M at any time t versus t is a straight line with slope minus k. Slope of this line is negative rate constant k. This is integrated rate equation for a first order reaction. You can write this as ln concentration of A naught divided by concentration of M at any time t equal K times T. Converting this into log to the base 10, which is log concentration of A naught divided by concentration of A at any time t equal Kt divided by 2.303 is integrated rate equation for a first order reaction. This is in terms of natural logarithm. This is in terms of log to the base 10. Example: the decomposition of hydrogen peroxide in dilute sodium hydroxide solution is described by the equation hydrogen peroxide decomposed into water and oxygen. Now the reaction is first order in hydrogen peroxide. The rate constant at 20 degrees centigrade is K. K is given equal 1.8 times 10 to the power of minus 5 per second. And the initial concentration of hydrogen peroxide, initial concentration A naught equal 0.3 molar. And what is the concentration of hydrogen peroxide after 4 hours? From an integrated rate equation for a first order reaction, we have this: log initial concentration A naught divided by concentration of M at any time t equal Kt divided by 2.303. Log A naught initial concentration is 0.3 divided by concentration of M after 4 hours. T equal K is rate constant 1.8 times 10 to the power of minus 5 times T time in second. Time, given time is 4 hours. In second is 4 times 1 hour. It's the same as 1 hour equal 3,600 seconds. Therefore, 4 times 3,600 seconds divided by 2.303. Solving for concentration of M. Concentration of M after 4 hours equal 0.23 molar. 23 molar. This is concentration after 4 hours. B. How long will it take for hydrogen peroxide concentration to drop to 0.12 molar? You are asked to calculate time. B. From integrated rate equation for first order reaction, we have this log concentration of N0 divided by concentration of M at time t equal Kt divided by 2.303. You are asked to calculate time t. Substituting the given value into this equation, we get the value of t equal 5.1 times 10 to the power of 4 seconds. This is your answer. Second order reaction. For a simple reaction, A2 product rate equal minus change in concentration of A divided by change in time. Again, rate equal K times concentration of A to the power 2. Now using calculus, we can write this as minus change in concentration of A divided by change in time equal K times concentration of A to the power 2. Rearranging this, we get minus change in concentration of A to the power of divided by concentration of A to the power 2 equal K times dt. Integrating both sides using calculus. An integrated rate equation for a second order reaction is this: 1 over concentration of M equal Kt plus 1 over initial concentration. This is integrated rate equation for second order reaction. You see, 1 over concentration of M at any time t equal Kt plus 1 over A0 is similar to equation of a straight line, which is y equal mx plus b. Now, a plot of 1 over concentration of M, 1 over concentration of M at any time t versus t is a straight line with slope k. The slope is positive straight line. This is graphical representation of second order reaction. For example, the reaction NOBr decomposed into NO and Br2 gas is a second order reaction with respect to NOBr. The rate constant K is given. K equal 0.810 molar per molar per second at 10 degrees centigrade. Initial concentration of NOBr0, initial concentration A0 equal 7.5 times 10 to the power minus 3 molar. How much NOBr, concentration of M at any time t is unknown, will be left after a reaction time of 10 minutes. What is concentration of NOBr after 10 minutes? Time t is 10 minutes. Now, an integrated rate equation for a second order reaction is this: 1 over concentration of M at any time t minus 1 over A0 initial concentration equal K times t. You are asked to calculate this concentration of NOBr after 10 minutes. 1 over concentration of M after 10 minutes equal K is 0.810 per molar per second times t in second. 1 minute is 60 seconds, therefore 10 minutes is 10 times 60 seconds, which is 10 times 60 seconds plus 1 over initial concentration. 1 over initial concentration of NOBR is 7.5 times 10 to the power of 3. 7.5 times 10 to the power of 3 molar. Now multiplying this, we get concentration of M after 10 minutes equal 1.6 times 1.6 times 10 to the power of minus 3 molar. Students, in our today's lesson, we learned concentration time equation or integrated rate equation for zero order reaction, first order reaction and second order reaction. Integrated rate equation allows us to calculate concentration of a reactant at any given time. This brings us to the end of our today's lesson. Until next time, goodbye.